All right, are you ready for exercise 4 now? Series circuits. So this is the picture at the end of exercise 3. We had the LED in there, and we had the ammeter set up in the flow of the current and the voltmeter across or in parallel to the LED. So what we're going to do, we want the same setup, except instead of the LED, we want two resistors in series. So what I'm going to do is pick the two resistors from the smaller resistors, and I'm just going to set them up in back of this LED here. And I'm going to stick the first one in the breadboard. Now, on the breadboard, the columns are connected together. So if I want to put another one in series, I'm going to put its leg somewhere right above the first one. Sometimes the legs get bent and they won't go in very well. So let's try this again. There we go. Alrighty. So now I've got the two resistors in series, and to make it easy, I am just going to get rid of the LED. It kind of popped off, and attach them across like that. So I still have my ammeter. It fell asleep, so now I have to go wake it up again. So I'm going to have to turn it all the way off. Turn it all the way over to the amp setting. Unfortunately, again, it defaults to AC, so I have to press the yellow button. And now we're on amps DC. And this one also fell asleep. Wake up! And it is now volts DC. So let's read the instructions. Locate two resistors from the last exercise. So I located two of them. I got the brown, black, brown one and the blue, gray, black one. So you look them up, and they're not that much. They're not over 200 ohms. So they're the smaller resistors. Okay, don't use resistors that have greater than 500 ohms. That's because the ammeter that I have it can't measure very low amperage. So I need low resistors, or else I'm not going to get any reading on my ammeter. Have your instructor check the circuit before applying power. Okay, I checked it out. Turn the power supply on and apply 5 volts. Okay, so turn the power supply on. And let's go up to 5 volts. Oops, I overshot it there. There, okay, so it's 5 volts on there. It's actually 5.015. All right, so look on your data table. Go to your data table and take the data as we read it off. So this is for table number 4, resistors in series. It says the total voltage applied to the circuit. The total voltage applied to the entire circuit is 5.015. You can see it right there. Total current applied to the circuit. Okay, current. There it is, 0.032 amps. So you see that? I'll write those things down. Now, how are you going to find the experimental equivalent resistance of the circuit? Well, from the last exercise, you did it in the third column. You used Ohm's law. V equals IR. So R is equal to what? Solve for R. And you use the voltage and the current. So what you do now is calculate that. Calculate the experimental equivalent resistance of the circuit using Ohm's law. So if V equals IR, then you solve for R, plug in the total voltage and the total current, and do the calculation and write it down in that spot. Okay. Now the next part is looking at each individual resistor. Each resistor is using up energy. There's a voltage drop across each of the resistors, and the voltage drop is proportional to how much the resistor is. So the resistor that's a little bit higher is going to have a greater voltage drop across it, but across the entire circuit, there's a voltage of 5.017, So the voltage drops across each of the individual voltages must add up to 5.07. However, or 5.08. However, the current is the same running through all of them. So on your little table, it asks for the current, the resistor number 1 and 2. We're going to call the resistor on the left number 1 and the resistor on the right number 2. The current is the same going through each of those and is the same as the current going through the whole circuit, or the total current applied to the circuit that we already wrote down from above. Okay. And again, the total voltage applied to the whole circuit. Now what I'm going to do is unhook the voltmeter from, it's actually, the voltmeter is attached here, so I'm going to unhook this guy right here. I've got it in parallel across the circuit, and I'm going to unhook this voltmeter here. So here's the other voltmeter. Yes, I'm not supposed to be touching it because it's live, but all right, so now I have my voltmeter leads. What I'm going to do is I'm going to put the voltmeter leads across the resistor on the left. So I need an alligator clip. So I'm going to hook up the voltmeter across only the resistor on the left, and then we're going to go look to see what the voltage is. To see how it's not 5 anymore, it's smaller. It's 3.02. So that's the voltage across resistor number 1. So fill that in your table. Okay, so now I'm going to disconnect that one, the voltage, and just hook it across the resistor on the right. Okay, that's all I did. There's a wire in the way there. So all I did is now I'm measuring the voltage across the right resistor, or resistor number 2. Oops. 2.047. Okay, 2.04. Well, now it's 2.048. It's probably warming up a little bit. Okay, 2.048. So that is the voltage across resistor number 2. Now the third column, actually it's the fourth column, says the resistance. Again, you calculate the same way you did before, as we did in exercise 3 and before, using Ohm's law. You take the current through each resistor and the voltage across each resistor and find the resistance of that resistor using Ohm's law. So resistor number 1, then you also do that for resistor number 2. Then the total calculated resistance for series is what? Well, in the theory section, you should have found out that for series circuits, the resistance, total equivalent resistance, is R1 plus R2. So from your table, you found the resistor number 1 all the way off to the right. You calculate the resistance. You add that to the resistance of number 2, and you have the total calculated resistance. Then all you have to do is find the percent difference with the experimental value. So the experimental value we found by using the total voltage applied to the circuit and the total current applied to the circuit. That was the third line all the way up. The third line when we started going down in table number 4. Now, the percent difference, remember, is the difference in the values divided by the average of the values. And then you multiply the whole thing times 100%. And then there's a couple more lines. Some of the voltages across both resistors. So take the voltage, this is 2.48, and you add it to the other one, which was 3.0 something. I can't remember what it is, but look it up. You add those two together, then you compare that with the total voltage across the entire circuit, which is the first number you wrote down for this exercise. Then again, you find the percent difference, and that's it for series circuits.